guys, so today we're going to look at percentage composition. So this is basically the reverse of what we were doing when we were determining the molecular formula of a substance. So remember, with molecular formula, you're given the percentage composition usually, and then you have to determine what the actual chemical formula of the compound is. Now we're going to do it the other way around. So they'll give you the chemical formula, or they might just actually give you the name of the compound. Then you need to go from the name to the chemical formula, and from that work backwards to determine how much of your compound is each of the different atoms of each of the different elements that make it up. Okay, so percentage composition, be careful, they might not use this word composition, okay, in the question. They could just ask you what percentage of hydrochloric acid is hydrogen. Okay, so you're looking for that word percentage. Okay, so percentage composition, there is a formula that we use. This formula is not given on your formula sheet, okay, so you have to learn it. And our formula is that the percentage composition of a specific element, whichever element we're after, is equal to the molar mass of that element divided by the molar mass of your entire compound. And now, because we're dealing with percentages, it's times 100. So a quick reminder, these molar masses, these capital M's, we get them off of our periodic table. Okay, so that's what we did on that last Monday before school closed. Okay, now for percentage composition, I'm going to do one that's super straightforward and easy, and then sometimes they sneak in something called water of crystallization. So I'm going to first do the normal straightforward one, then I'll pause you, and then we'll do water of crystallization. Okay, so for our example, we're going to determine the percentage composition of sulfuric acid. Okay, now note the wording here. I've said the percentage composition. That means I want to know how much does each element contribute to the overall mass. Okay, what percentage does each element contribute to the overall mass? If I said what percentage is hydrogen, then you only have to determine hydrogen. Okay, but because I've said percentage composition, we have to do it for every element that makes up that compound. Now, before we can start, we actually need to know what this thing's molecular formula is. Hopefully we know it. It is H2SO4. Okay, so we're going to be using this formula for this whole thing. We're going to be doing it each time for each element. So our compound here is made up of 3 different elements. We've got hydrogen, sulfur, and oxygen. So we're going to do it for each of them. Okay, so starting with hydrogen. We're going to say the percentage hydrogen is the molar mass of hydrogen in our compound. Now be careful. We know the molar mass of hydrogen is 1, right? But I don't only have 1 atom of hydrogen in here. I have 2. So you take the molar mass of hydrogen and you multiply it by how many hydrogens you have. Okay, times 2. This 2 comes from the fact that we have 2 hydrogens. And we're going to divide that by the molar mass of H2SO4 and times that by 100. Okay, now if you want to, you can do a little side calculation to first figure out our molar mass of H2SO4, because we're going to have to use that number 3 times. So I'm going molar mass of H2SO4 equals twice the molar mass of hydrogen, so that's 2 times 1, plus once the molar mass of sulfur, which on my periodic table is 32. Again, I'm using a different one to you guys. Sorry, I left mine at school, so if my numbers are a little bit different, I'm sorry. And then plus 4 times the molar mass of oxygen, which is 16. Okay, and when we add all of those together, we get 34 plus 4 times 16, 98. Okay, so our overall molar mass for sulfuric acid, 98 grams per mole. Okay, so now we're just going to go and stick that into this equation here. So we've got the percentage hydrogen is equal to 1 times 2, so the molar mass of hydrogen 1, over the molar mass of our whole compound, 98, times 100, and we get 2 divided by answer times 100, 2.04%. Remember, 2 decimal places. Okay, so we've got 2.04% for hydrogen. Okay, next up, so we've done hydrogen. We must do sulfur, we must do oxygen. Okay, see now. Sorry. We must do sulfur, we must do oxygen. Okay, so sulfur first. We're going to do S. Percentage sulfur equals the molar mass of sulfur over the molar mass of our whole compound, which is H2SO4, sorry. And now let's double check how many sulfurs have I got? 1, so I don't have to multiply this by anything. And then times 100. And we're going to substitute in. So for sulfur, where is it? 32. And my entire compound is 98, and we're timesing that by 100. And we should get roughly 30%, it looks like. 32 divided by 98. So we get 32.65%. Okay, and one more, we're going to quickly do oxygen. I'm hoping you can probably go ahead and do oxygen yourself now. But for oxygen, we're going to go percentage oxygen equals, and we're going to do the molar mass of oxygen, but now we always double check how many oxygens do I have? 4, so I must times that by 4 over the molar mass of your compound. I keep writing compound, sorry. H2SO4 times 100. We're going to substitute in, so I'm going to just work horizontally now because I don't know how much of the board you can see. So we're going to have 16 times 4 at the top over 98 times 100, and then you're just going to stick it in your calculator. So we're going to have 16 times 4, oopsie, over 98, and we get 65.31% for oxygen. Okay. So I'm going to pause you there, and we're going to look at water of crystallization in a sec.